Hello everyone and welcome to today's Chemistry Daily Booster. This is number 18 in our Paper 2 series and it is still advanced information listed for both the Foundation Chemistry and Higher Tier Chemistry. What we're going to be looking at today are some different materials then. So the first material we need to know about are these things called ceramics. So when we're talking about ceramic materials, we're talking about brick, china, glass, porcelain, etc. Now, when we think about what the ceramics actually have as their kind of key points, if you like, they're hard, non-metallic materials. And they will contain both metals and non-metals that we've combined to form this giant ionic lattice or a giant covalent structure. Obviously, which one depends on what it's made of. But they have certain properties in common with each other. They have high melting points. They're hard, stiff, brittle, poor conductors of electricity, and poor conductors of heat. Now, these properties are actually going to be very useful when it comes to some of their uses. On the most part, our ceramics are made of oxides, and as a result of that, they're quite unreactive. If we have a look to see how we make those 4 key ceramics that we've mentioned. Glass, we're just going to take sand, heat it to melting, and then allow it to cool. Brick, we're going to take our clay, shape it into, obviously, brick shapes, heat it up, and then that will form our bricks as it cools. And then finally, our china and porcelain, heat our clay up to high temperatures, and then we're going to coat it in a glaze before we reheat it. Now, the reason that heating things is going to actually lead to forming something completely different from our starting point is because if we think about what happens with sand first of all, when we melt the sand and then cool it, what's going to happen is we form a giant irregular structure, and that doesn't have crystals present. If we compare that to sand, which is all about the crystals, then what we've done is completely changed the way those atoms are held together. So we get completely different properties between the sand and the glass. If we think about when we heat clay up to high temperatures, what we're really doing there is creating these tiny crystals, and they're actually joined together by these little tiny bits of glass that hold it into that structure. In some cases, what we find is that just an individual material on its own is not as useful as it could be. So what we've actually developed are things we refer to as composite materials. Now, a composite material is made from 2 or more materials that have got different properties that we're then going to combine together. The idea being that our composite material has better properties than the individual materials it's made from. So if we think of some examples then, we've got fiberglass, which is little glass fibers embedded in a resin. Now, glass obviously on its own, not overly useful. Fiberglass, however, we can use in things like canoes. You wouldn't make a canoe out of just glass for obvious reasons, but fiberglass is actually excellent to make a canoe out of. We also use things like carbon fiber, and that's in our sports equipment, racing cars, etc. So again, those are small fibers of carbon there. So what we can do is just combine those with other materials like the resins, and as a result we've now made a better material with more useful properties. One of the most common examples is concrete. Now, concrete is a composite material that we make from aggregate, which is basically little bits of rock, sand and cement, so that when we add the water we have chemical reactions occur that bind the whole lot together. Now, concrete on its own actually has this high compressive strength, so when you push down on it, really strong. So that means it's great for foundations in buildings, because obviously buildings are quite heavy, therefore you need something that can withstand the force pushing down on that base. However, it does not have great tensile strength. So if we were just to build beams out of concrete, they would actually crack when we place loads on them. And that's not great if we're thinking about the 2nd or 3rd story of a building. You don't want the concrete beams cracking. Another material is steel. That's got a high tensile strength, so that can withstand quite significant loads being placed on it. But steel on its own is not great in terms of its compressive strength, and it's also prone, obviously, to rusting, as we established earlier. Therefore, what we do is we tend to use steel reinforced concrete. That's our composite material. We're actually going to embed steel rods in the concrete itself, and that means we get the best of both worlds. We get the high compressive strength of the concrete and the high tensile strength of the steel. So that means we've now got a very useful building material in a steel reinforced concrete. In terms of the kind of question we could be asked with regards to materials, this is a common one, where they're going to give us a table of information about different materials and then ask you which one we should use for a particular purpose and get you to justify your choice. Now, when it says to justify your choice, number one, make a choice. So think about the actual job, look at the information and select the best one there. There's probably going to be some benefits and some drawbacks for all of them. So you're picking the one that's the best fit. When you're justifying, you then need to say, I would do this one because, however, there is a downside here. I would not use this one because, and I would not use the other one because. So make sure you explain all of your reasonings in this answer to get maximum marks, particularly if it happens to be a 6-marker. We now need to consider what we refer to as a life cycle assessment. Quite simply, life cycle assessments are where we're looking at a cradle-to-grave analysis of the impact of the products. So making them, using them, disposing of them, we consider the lot. And realistically, what we're doing here is trying to identify stages that we can improve or swap materials for alternatives that can do the same job. The end result is really to try to minimize the environmental impact, maximize the lifespan of our product, and make sure that it is a sustainable process that we're using to make it. Why do we really care? Well, if we generate a load of rubbish, which we do as the human race, then the vast majority is going to end up in landfill. Sadly, we still don't recycle enough, so anything that's not recycled just ends up in these massive landfill sites. They're problematic for a number of reasons that we won't go into today. Recycling is one of these very important things that we should all try and do, because it's going to conserve these raw materials and energy resources, because we're not going to have to use lots of energy to extract them. It's going to reduce the release of harmful substances into our environment, and it reduces the amount of waste we create as a human race. It's not just an easy thing to recycle, however. You can't just say everything will be recycled full stop. There are certain factors we need to consider here. Firstly, how easy is it to collect and sort the waste? If you've looked at plastics, you've probably noticed the fact that they come in all different types. Only some of them are easy to recycle. So when we're all just lobbing plastic in our recycling, some of it actually won't recycle that well. And therefore we've got to have some kind of method of sorting out the different plastics and making sure that the ones that aren't recyclable don't make it into that end process. We also need to consider the amount of energy involved at these stages and any byproducts we're going to release through the recycling process. And finally, the cost that comes into that does need to be considered versus landfill or incineration. So how do we do this then? Well, we'll collect the materials, and you probably have some kind of method of recycling where you live, boxes, bins, bags, something that the council will come and collect, and then it's taken somewhere for sorting. Different materials are then recycled in different ways. If we're talking metals, then we melt them and then we pour them into molds to produce these things called ingots. If it's paper, we're going to mix it with water, clean it, roll it, heat it, and then we've got new paper from it. Glass, melt it again and mold it. And polymers, we melt and we mold into new objects. So realistically, if you're not certain about how we actually go through the process of recycling material, melt it and mold it into a new shape is always a good place to start, as we can see. As always, if you'd like to look at any of these in more detail from the booster, then have a look at the C6 playlist on the main channel. Also use your revision guides and have a look at some of the past exam papers to see the style of questions. And then don't forget to join us again tomorrow for our next Chemistry Daily Booster.